Alright, so let's take a look at related rates, day 2. So we got kind of a quick little warm up here. We're given a trough that is 10 feet long and 6 feet across at the top. The ends are isosceles triangles with an altitude of 4 feet. If water is being pumped into the trough at a rate of 9 cubic feet per second, how fast is the water level rising when the water is 2 feet deep? So the first thing I'm going to do is I'm going to draw a trough for you. A lot of times people say, what's a trough? It's that triangular thing at ranches that animals kind of eat out, like a pig or something like that. So there's our trough right there. It looks kind of like this. We know it is 10 feet long, so there's 10 feet long right here, and 6 feet at the height right there. And we know we have an altitude here of 4 feet. We're told water is being pumped in. So I'm going to go ahead and list out my givens. We're told water is being pumped in at a rate of 9 cubic feet per second. So hopefully remember that is like my change in volume. dV dt is positive because we're pumping water in. Remember, if water was leaking, we would make it negative. And how fast is the water level rising? So they're looking for the change in height. So how fast is that water level rising? That's at dH dt when the water is 2 feet deep. So when the water has a height of 2 feet. So let's see here. So if I look at the shape right here, this isn't too bad to do. If I want to find the volume, so I'm going to give everything a variable here. Remember my rule? Remember the rule? If it changes, it gets a variable. As water is being poured in, the height will change here. So that 4 feet, that's kind of like my h. But the length will also change. So I'll call this L. But what about this 10 feet? As water is being pumped in, that 10 feet never changes. So I'm going to leave that alone. So this is a constant. So I'm going to leave that alone. And when I want to come up with the equation for my volume, this is a triangular prism. So we know it's the area of the base, which is a circle, 1/2. I call the base L and the height H. And to get the volume, we're going to multiply that by 10. Now again, anything that has a variable changes. Anything that has a variable anything that changes, gets a variable. So my length that the water is and the height of the water will always change. The 10 is the length of the trough. That's always going to be constant. So I can also write my volume then as 5L times H. We had a problem like this yesterday. We are going to have to replace L or H. Well, which one do we replace? Well, looking at the problem here, we're given H and we're looking for dH dt. We don't need L. So I am going to replace L. So to do that, I'm going to use my similar triangles just like yesterday. I know that the length is 6 when the height is 4. So I can get my relationship length to height, and that's going to be 6 over 4. So therefore, I know my length, L, is going to be 3/2 H. And then I can write my new volume. 5 times 3/2 H times H, or 15/2 H squared. Taking our derivative, I ran out of room here, dV dt, that's going to equal 15H dH dt. And I can just plug in everything. dV dt, we get 15. dV dt, that's what we knew. Sorry about that. We know that that is 9, so we should get 9 equals 15 times H, which we're told is 2, dH dt. So we get dH dt equals 9 over 30. And you can reduce that to 3/10 if you like. The unit height is in feet, and my change in time will be in seconds. And we could write our answer. The height is increasing at a rate of 9 over 30 feet per second. And there's your answer. So there's a couple hints here that we got to remember. Hint number 1, right? If something is increased, if the distance increases, we say the velocity is negative, is less than 0. If the distance decreases, we said that the velocity is greater than 0. That's less than 0. And hint number 2, this is the big one, if it changes, it gets a variable. That's why we didn't put a variable in the tent. It doesn't change. But the length of the water and the height of the water will change in this problem right here. Alright, so let's take a look at number 2. Alright, Luke is fishing. Okay, Luke is fishing for ewoks off the top of a 16-foot tower. Upon catching one, he reels it in at a rate of 2 feet per second. Now, when he reels it in, he's fishing, so this is the line. The fishing line. So I'm going to draw a picture here. Always draw a picture if you can. On top of a 16-foot tower, and Luke catches an ewok, and he's reeling it in right here. So the question says, at what rate is the ewok being reeled in when there is 20 feet of line out? When there is 20 feet of line out. Boy, don't ever correct my grammar. That's the reason I majored in mathematics. So, where is that 20 going to be? Of course, that's going to be here. That's the line, right? And this height we know is 16. And let's see here. Now we're going to identify everything, give everything a variable. Remember, if it moves, it gets a variable. If it changes, it gets a variable. As you're reeling in, this line is going to get smaller and smaller and smaller. So we'll call this C. It's part of our triangle anyways. The distance the ewok travels, the ewok is going to travel towards the wall. So that distance is going to change too. So we'll call this B. This distance right here, A, B, C, I just used the right triangle. A here will not change. This is a constant. So even though I have a variable, I'm not going to worry about calling it a variable. So now I'm going to list out my givens. And the first thing they tell me is that he is reeling the ewok in at a rate of 2 feet per second. So that affects C. They're giving me dc dt is 2 feet per second. I'm not done. It's going to be negative 2. Why is this going to be negative? Because that distance is decreasing. Very good. We want to know at what rate, what is the rate the ewok is moving. So we're looking to find dB dt. So we're going to go ahead and solve this. So we need an equation. So it has a right triangle. So I'm going to use my Pythagorean theorem. That's pretty easy. A squared plus B squared equals C squared. So remember, though, A was constant, so I can just leave this as 16 squared plus B squared equals C squared. And when I take their derivatives, the derivative of 16 is just 0 plus 2b, remember this is implicit, dB dt as a related rate. Both b and c are functions of time, so we're going to go dB dt equals 2c, and don't forget your dc dt. So there is our derivative. But if you notice, we need b. Okay? So we need b. So let's go ahead and do that. I can do some math. B is just the square root of 20 squared minus 16 squared. And I already did this for you. You get 12. So B is 12. So if I plug this in, we would get 2 times 12 dB dt, which is what I wanted, equals 2 times C, which is 20, dC dt, which is negative 2. And solving dB dt, we would get, what's that? Negative 4, so negative 80 divided by 24. And if you simplify this, you just get negative 10/3. Let's talk about the units. B is measured in feet. T is measured in seconds. Now the negative means he is heading towards the tower. So let's go ahead and write that. Remember, the negative says that the distance is decreasing. So the tower and the Ewok, that distance is decreasing. So that tells me the Ewok is moving towards the tower. So we can say that the Ewok is moving towards the tower at a rate of 10/3 feet per second. Now, if you say the Ewok's distance is decreasing at a rate of 10/3 feet per second, that's okay too. But by moving towards the tower, again, this number is always going to be positive. But the Ewok is going to be moving away or towards the tower. That's what the sign tells me. He's moving towards the tower. So I don't need to put a negative here if I'm already saying he's moving towards the tower. And that would be our answer there. All right, going to part 2, we'll finish up this one, the angle question, and we have another example there. It's a really good problem for us.